of the questions, remember the second project proposal should include the model and the theoretical framework, at least 5 papers with the same idea, where we can find the results expected, okay? And on the other hand, the model should be exposed in a visual way, okay? And any questions? Maybe clear?
Yes, teacher. I think there's no questions.
Okay. Okay. Thank you, Daphne, Adriana. Thank you, guys. Okay. If you don't have questions, I will share with you the last topic on in the last class. I didn't finish the topic of sampling. So today's class I will complete this topic of sampling, and then I will try to explain about the hypothesis testing. Okay. Just wait a minute to share my document. Don't worry, Arlen, okay? No problem. Okay. In the last class, I talked about the sampling, so but I didn't finish the topic with the formula. This is the formula. This is the general formula. There are more formulas about the sampling, depends of the other parameters, but in general terms, this is the main formula in which n it's the number of observations, e is the desired error, zeta alpha divided by 2 is the zeta table. Remember the zeta table? So this is the number of this variable, and this number is this letter, the sigma, is the standard deviation. Okay, so this, if you work with this formula, you can reach out, or yeah, you can reach out this formula in which the idea remains, but you need to change one parameter in this formula. You need to use P and Q, where P is the fraction of population that you need to measure, and the rest of the population is Q. So it's important to say the following idea. The next idea, if P is a noun, you don't know the fraction of population, you can use P equal to 0.5. In this case, N will be the maximum possible value. In this case, you you will obtain the maximum number, okay, of the observations. This is an example to understand no, not understand. Well, yes, understand, but to 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 use the formula, okay, to understand better the formula. If we work with this formula, we can get the number of observation. Okay, we can make the sampling. The exercise is, is the is the is is the following. Okay, the reaction of an individual to a stimulus in a psychological experiment may take one of two forms. Okay, one of two forms, A or B. If an experimenter wishes to estimate the probability P that a person will react in manner A, how many people must be included in the experiment? Okay, to one of two forms, A or B, the probability P that a person will react in a manner A. Okay, how many people must be included in the experiment? Assuming that the experimenter will be satisfied if the error of estimation is less than 0.04, with probability equal to 0.90. Assume also that he expects P to lie somewhere in the neighborhood of 0.6. We need to use this formula. Okay, in this formula, we need to find the Zeta table. Remember, what can you find in the Zeta table? Probabilities associated to an statistic. So in this case, the probability, what is the probability? What the probability is the probability is 0.9, okay, 90%. So what is the p-value? 1 minus 0.9, okay? This is we need to find the probability. 1 minus 0.9, okay, 0.1. We need to check the Zeta table. Let me share with you the word
Teacher, I
where.
have a question.
Sure, tell me.
Okay, you told us that sigma is the standard deviation, but alpha, what is?
Okay, wait a moment, Mariana, please can you repeat the question, Mariana? Sorry.
Yes, you told us that sigma is the standard deviation, but alpha, what represents? In here is the
Oh,
value of theta.
okay,
Of
okay.
C.
I got it, Mariana. Thank you for your question. The the value of alpha is the probability to make the type 1 error. On the next minutes, I will explain what is alpha, but in this case, it's necessary to understand that alpha is the probability associated with the Zeta table in this moment. Okay, Mariana? Only that in the next minutes I will explain in other words, in deeply way, what is the alpha. Just to finish this exercise, I will calculate the sampling, but your question is important. I will be back with this idea on the next in the next minutes. Okay, Mariana?
Yes, and another question. You just told P is population, and Q, what was it?
Okay, Q will be the rest of population if P is equal to 0.8 e- e- equals to 80%. The value of Q will be 20%, 0.2. Okay, is the complement. Okay, all good.
Okay, and the E, or are you gonna explain it later? The letter E.
Okay, the E eh, indicates the desired error, but I will be back with every variable. The first variable is the Zeta table. So for 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 this motive, I will share my not my the Zeta table, okay, Mariana, but I will explain every variable, each variable
Yes, thanks.
after that. Okay, Mariana. Thank you. If you have any question, please tell me as Mariana. But let me show the Zeta table before of that. Okay, the Zeta table, we need to find the probability associated with the alpha. Remember that alpha, the alpha is 0.1. Okay, the value of alpha is 0.1. If you divide the 0.1, the 10%, divided by 2, you will obtain 0.05. Okay, if you find this number in this table, 0.5, 0.45, and so on, you need to find 0.05. This number 0, let me show. This is the number 0.05. Okay, and this number is 0.0495. The is as you can see, the number that we are finding, we are searching, if the number of 0.05 is the number just between these numbers. Okay, it's exactly between these numbers, between one, check this number, 1.6, 1.63, no, 1.64 and 1.65. It's exactly between the 1.64 and the 1.65. Let me change the document. Okay, this number, remember, between 1.64 and 1.65. It's a number between, just in the middle of these numbers. So what is this number? The Zeta table, alpha divided by 2. This number is exactly the same. It's this number plus this number divided by 2. Why divided by 2? Because it's exactly in the middle of this number. Okay, this value is this number, but we need to raise okay, we need to obtain the square of this number. So this number will be raised to 2, okay? 2.17, 2.70, sorry. It's this number, okay? So the next variable p, remember as Mariana asked, what is p? P is the fraction of population. In this case, in the exercise, in the example, we can use a value of p 0.6, this fraction of population. So set a table I will use. Next, it's p. It will be 0.6. The next variable q. What is q? The rest of population. So 1 minus 0.6. And finally, the error. What is the error? Is this number will be in this part 0.04. Okay, this is the number 0.04. So what is the value of n? Calculating this or employing this formula, set a table square of set a table times the value of p times q, all this number divided by the desired error, 0.04, will be this number raised to 2, okay? Even we can employ this formula. Let me show this formula, okay? It's exactly the same. This is exactly the same. The number of observations that you need to include in this study is 406 people. Okay, this is the number of observations.
Teacher.
Okay, tell me, Daphne.
No, Adriana. I have a question
Yeah,
about. I get confused. 1.64 and 1.65. The alpha. How do we get that?
Okay,
I
okay.
didn't understand.
Okay, no problem, Lorena. But the idea of what is this value, is it clear, or you have question about the whole idea of this value, or only to find the number?
Oh, I
Okay,
just
okay,
understand the error.
okay, but no problem. The Sera table, remember, it's an statistic that you can employ in certain times. In this case, to obtain the number of observations, the sampling, we will assume a normal distribution. If you have normal distribution, you can use set a table. Remember, set a table. Let me remember. Okay, wait. Let me change the document. Wait. Okay, guys. Remember the value of every value of this table represents a probability. Okay, probability of what? Probability to find a number, a theta value expressed in standard deviations. Remember, this table, this Zeta table, associate the probability, each probability with the Zeta value. The Zeta value is the expression of the difference between a number and the mean divided by the standard deviation. So what is this Zeta value? A number expressed in the standard deviation. So in the exercise, the idea, the necessity, or the idea is to find the probability associated with the zeta alpha divided by 2, with alpha equal to 0.1 or 10%. Okay, because we need to a level of significance of 90% or 0.9. So the value of alpha, that value will be 0.1 divided by 2. So this value is 0.05. Okay, is it clear in this moment?
Teacher, I'm sorry, every time will be 0.5, or just when we don't know the value?
In this case, in the exercise, they tell us the value. Remember, the value, the probability will be 0.9. After to share this word, I will be back with the Excel to see this question. Okay, this value.
But I don't understand. I mean, why do we choose
okay,
vertical line 1.6 and the horizontal the point
okay.
0.4?
It's clear your question. Okay. Maybe I make the mistake. I made the mistake of not explain the way to find the zeta value. But I saw you in the last class, but maybe you can have questions or doubts, but don't worry. The zeta value, this number and this number is the zeta value. For example, if you are looking the probability of 30.15%. Okay, this number. What is the value, the zeta value associated with this probability? In this case, the value of zeta will be 0.5 and then 2. Okay, 0.52. You can read this number, 0.52. Okay, in another case, if you are looking the probability associated with a zeta value of 0.25, for example, 0.25, the probability associated with this zeta value is 14.13% or 0.4013.
Teacher,
It's okay. Tell me, Adriana.
I get it. And so the question will be why do we choose 1.64 and the other one?
Okay, perfect. Look, this number 1.6640 and 1.665 is because we need to find the probability of 0.05. And as you can see, this value doesn't appear or does you can find you can find in you can find in this data table, you can find 0.505 and 0.0495, but the exactly value you can't find in this data table, but you can obtain in just with the average or the mean, because 1.64 is associated with probability of 0.0505, and the next number of theta value is 1.65 associated with this probability. So you can find the value of 1.645 because the value of probability is exactly in the middle of these values. Okay.
So teacher, this 0.1 was because our possibility needs to be of the 90%, and that represents, no, yeah, the 0.1 of possibility, and the 0.5 is represented between 1.64 and 1.65.
Exactly, but you are explaining in a perfect way. Only I need to complement your idea. Remember, the 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 value one the value of 0.1 is the probability that we are looking or we are searching, but we need to divide this number by 2. Okay, so the probability that we need to find is 0.05. Only that, okay?
Okay, and you wrote down this 0.1 like 1.645. That's the value in in here in this table, right?
Exactly, exactly.
And you wrote also down 1.64, 2.70, but I didn't understood from where you get that number. That
Okay,
one, yeah.
Okay, Mariana, perfect. Look this number. It's only the square of the theta table because in the formula we need to employ the exponent 2. Okay, only that, but no problem if you erase or forget this number. Okay, in the formula I will I calculated with the theta table. This number 2.70 is only this number. Okay.
Yes, and I got lost also in the 1.65 will be the same. It will be the square of that number.
Can you repeat the last question, the last part of the question, please? I don't understand. I didn't understand very well.
Yeah, if the 1.65, it's also the same like the square of that number.
The 1 point, this number, Mariana?
Yes, if down will be the, how you told us, like the square will be the same.
No, this number is only it's only the, in other words, is the inferior, or the, not the inferior, the lower value and the upper value. Only that these two numbers is the, it's that the numbers of the theta table. So I will I use this number only to find the theta value. Okay, only that this
Oh,
number.
okay. And sorry if I am asking too much, but I got lost.
No,
And
no,
this
no.
0.6, I got lost with what is that, the rest of the population, or what is it?
Exactly. In wait, in an experiment, the scientific should should know the population, the total population. So if you, for example, males and females, it, but in the cases when the scientific doesn't know the population, the fraction of population, the scientific should employ a, a number p of a value of p of 0.5. Okay, the this is the fraction of population, but if you don't know the fraction of population, you can employ 0.5. And check guys, what happened with the number of observations if you change the value of p. If you change this value, assuming that we don't know the p-value, the p-value associated with the fraction of population. If you employ 0.5, look this number. Okay, what happened with this number? This number in this number of for the number of observations has been increased. Okay, this number is greater than the last number. So remember, if p is in a noun, you can use p equal 0.5 like this. In this case, n will be the maximum possible value. Okay, if you don't know what is the value of p, you need to use 0.5. But
So, teacher, this other where you were explaining, sorry, it's like another example, like doing with other variables than the one before, right?
exactly, Mariana.
Okay, I
The
only had
same.
one last question about the
Okay,
error. How
okay, the
do we
error.
calculate it?
Sorry, Mariana. Tell me.
I was asking how we calculate the error.
Okay, the error in a research or in an experiment. For example, you are calculating whatever, you are calculating some parameter with your population of Nuevo León. The error, this number, the letter E, or not the letter T. Okay, the number E, it's is the error margin, or the desired error. For example, you in your experiment, you need an error of 0.2, or in percentage 20%. In this case, the error will be 0.2. Okay, check what, please see what happened with the number of observation. If you change the error, the number of observations fall. Why this number is less than the last number, is less than 400, because the error, the possible error is less. Okay, so if the possible error is less than the last number, so in the result will be, you need to use a lower number of observations. Okay,
Teacher,
tell me, please.
I do understand the P and the Q and the error, but I still have a question about the alpha. So I just want to understand probability equal to 0.90. The I mean, there's a table that give me the 1.64 of that probability.
Exactly, but mm, are you Adriana, okay, or not?
Yes.
Okay, Adriana. Did only one comment for your question. You are understanding in a excellent way the idea, but this p value, sorry for the use of p and p in both cases, but this p value is the probability associated with the experiment. The, instead, this p-value is the fraction of population, but this p-value is associated with this probability. If the probability is equal to 0.9 or 90%, the probability associated with this number is 0.1 or 10%. So in the formula, we need to employ the alpha divided by 2. So this 0.5 divided by 2 is equal to 0.05. Okay. In this case, we need
Okay.
to, okay, in this case, we need to find the, let me set this idea in the Excel. Okay, so you need to find the value of the zeta value of the zeta table associated with this probability. So for with this objective, we found the lower and the upper number, 1.64 and 1.65. The zeta value, it's exactly in the middle between these values. So the zeta table is 1.645.
Yes, teacher,
Okay.
I get it. It's clear. Thank you very much.
Okay. No, thank you. Uh, Guys, please, if you have any questions, tell me. It's important for me and for the rest of the class. I think that all of you um, understand this idea, but I need to change the topic. Okay, so this is the assignment 6. In the assignment 6, you need to answer, you need to calculate the sampling in 3 cases, in 3 different cases. Okay, you remember the assignments, it's to carry out on Mondays. This is the assignment 6. You need to find the number of observations. Anyone has a question about the sampling, or we can change the topic.
Yes, teacher. Have you said the name of the formulas?
Please, Adriana, or no, Adriana, no. I don't know your name. Please, can you repeat the question?
Yes, I'm Susana. What are the names of the formulas that we are seeing?
The for
Names.
the assignment.
No. For the formulas that we already saw, like this class, the ones
Okay,
in the red squares.
the general name, the only the name, Susana.
Yes, as in how can we find them?
Okay. I got it, Mariana. Okay, the name of this formula, it's only the sample. You can find if you find or if you search the sample of population or calculate the sample of population, you can find this formula is the main formula. You can find other formulas for sampling, but this is the basic. Okay, depends of which formula you can employ. Depends of the parameters that you have in the about the population. So if you have the standard deviation of population, you can employ this formula directly. Okay, but in the exercise, the standard deviation doesn't appear, so we need to find the number of observation, the sampling with another formula. Okay, Susana, but the name of the formula is it's sample of population, only that.
Thank you very much.
Okay, no. Thank you, Mariana. And just to complement my last comment, sample of population, this is the name of the formula, and this formula is associated with normal distribution. Only that. Why is important to know that this formula is associated with normal distribution? Because if you don't know the standard deviation, but the population is large, you can assume normal distribution. In this case, if you have normal distribution, you can employ this formula. Okay. Okay. Questions about that, or you can see the difference? It's exactly the same, but expressed in other terms. Okay, guys.
Yes.
Okay, thank you, Susana. Thank you, guys, for the understanding of this topic. I need to change of topic. Let me change the screen. Okay, on the next in the next minutes, we will see the most important idea of statistics of this class. On the final in the final project, you need to use or an regression analysis or something like that. For example, another statistical test. But this idea, if you understand these ideas, you can understand what is the regression analysis. Other thing will be how to fix the regression, or how to um, adjust the regression. But in general terms, if you understand these ideas, you can understand what is the regression analysis in words. Okay, in a logical way. Okay, so this is the next topic. about the hypothesis testing. In the hypothesis testing, it's important to know the elements of a statistical test. Every statistical test, all statistical tests should contain these four elements. The first one, the null hypothesis, denoted by H0 or H sub 0. The null hypothesis. What is the null hypothesis? The hypothesis to be tested. Okay, but what is the alternative hypothesis denoted by H sub A? This alternative hypothesis is the hypothesis that we seek to support on the basis of the information contained in the sample. So the hypothesis to be accepted in case of null hypothesis is rejected. So in other words, in a scientific research, for example, in your final project, the alternative hypothesis will be your research hypothesis. Okay, always the research hypothesis in a quantitative research will be the alternative hypothesis. In my thesis of the PhD, my alternative hypothesis is the research hypothesis. But in the statistical test, I will test the null hypothesis. Why? Because it's the way to work, the way of work to work of the statistics. Always you need to test the null hypothesis, but your research hypothesis is the alternative hypothesis. Okay. I hope that I expect that this idea will be clear from now on for the rest of the class, or for the rest of your life in wherever you are working on the future. And the third element, the test statistic. What is the test statistic? It's a function of the sample measurements on which the statistical decisions will be based. In the last exercise, I used the SERA statistic. Why the SERA statistic? Because the SERA statistic is related to the normal distribution. So I made inference with the normal distribution. So for this idea, I used the SERA value. In this case, the test statistic is SERA value, but exist, or there are some a lot of test statistics. Okay, and finally, the fourth element is the reject region. The reject region. The reject region specifies the values of the tested statistic for which the null hypothesis is to be rejected in favor of the alternative hypothesis. So you can find the summarize of the reject region and the importance of the reject region in this phrase, on this sentence. For a particular sample, the computed value of the test statistics falls in the reject region. The reject region will be some number or some relation. if I will explain with numbers this idea, but first the theory, or not the theory, the ideas in a logical way in words. If the value falls in the reject region, we reject the null hypothesis. Okay? If you reject the null hypothesis, you should accept the alternative hypothesis. Okay? If the value, instead, if the value of the test statistic doesn't fall into the reject region, we need, or we should accept the null hypothesis and reject the alternative hypothesis. Okay? Is it clear this idea? If the value falls in the reject region, we should reject the null hypothesis. So since the name of the element is reject region, the consequence, if the value falls in the reject region, we need, or we should reject the null hypothesis. Okay? Do you have any question with these ideas in words? I will try to explain these ideas with numbers, but in words, do you have any questions, guys? No? Alison,
Teacher,
Paola, do you have questions? Tell me.
it's like, for example, in our investigation, for example, the hypothesis. We want to know if the students trust in the political parties or not. And for example, in the survey, the results tell they don't trust, like, or hypothesis. That's the alternative because um, the no was rejected. The no was that they do trust. Is that correct?
Mm, I need to see the complete survey, or whole the whole idea, all the questions. What is your name?
Adriana.
Oh, sorry, Adriana. Sorry, oh, Adriana.
No problem.
I need to see the general view of your research. I need to see all of all questions to to say to say how can you find the, or how can you prove your hypothesis, but in general terms, if your your idea is correct, but I need to see the questions to know how can you test, or how can you prove that. But the hypothesis in general terms is the correct. Okay, okay, Adriana. But
Yes,
I
like
need
the
to,
example for to understand this.
yeah, yeah, just only that. But maybe or no, it's correct. Only in advance, I need to, I I I need to see the questions, because I I am telling that because maybe you need to employ another statistical test, not the regression analysis, but I need to see that. Okay, okay, Adriana. Maybe I am thinking um, forward or not forward. But you're okay. I understand your comment, and you are correct. Okay, Adriana. Maybe I don't know how to say adelantándome, but only that, Adriana.
Yes, teacher.
Okay.
In fact, we are survey, and the next Monday we have the meeting with you, and I will
Perfect.
present some of them.
Perfect, perfect, Adriana. Excellent. Thank you, Adriana. Okay, these are the elements of a statistical test. The next in the next slide, I will I I I will share the what is the I will try to say what is the alpha. Remember, I don't know if Mariana or Adriana uh, did a question about the alpha. So this is the 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 ex, the idea related to this question. So in hypothesis testing, you know the four elements, but the next topic will be errors and p-value. In a scientific research, in quantitative research, you will never find the type 1 error or the type 2 error or the null hypothesis or whatever. In a formal scientific research, in a quantitative research, you always find the p-value. What is the p-value? Before of that, we need to understand what is the type 1 error and the type 2 error. Okay? The type 1 error is made if the null hypothesis is rejected when the null hypothesis is true. Okay? This is the type 1 error. The probability associated with the type 1 error is denoted by alpha. So what is alpha? Alpha always is the probability to make the type 1 error. And what is the type 1 error? When the null hypothesis is rejected, when the null hypothesis is true. Okay, this will be important, but I will be back on at the end of this class. A type 2 error is made if the null hypothesis is accepted when the alternative hypothesis is true. The probability related with this error is denoted by beta or beta. Okay, alpha and beta. And this paragraph or this sentence summarizing or not summarize all the ideas. If W, just to put a name W, you can say Sera or whatever. It doesn't matter. If W is a test statistic, the p-value. Remember, in a scientific research, you always find the p-value. It's the most important thing in scientific research, in quantitative research. The p-value or attained significance level is the smallest level of significance alpha, for which the observed data indicate that the null hypothesis should be rejected. In other words, what is the p-value? P-value always will be the probability to make the type 1 error. Okay? In the case where the null hypothesis is rejected, when the null hypothesis is true. Remember, the null hypothesis it's not the research hypothesis. The research hypothesis is the alternative hypothesis. But what is your purpose to make an statistical test? Your purpose or your objective should be reject the null hypothesis. Why reject the null hypothesis? Because you need to accept your research hypothesis. And what is the research hypothesis? The alternative hypothesis. You need to reject the null hypothesis. This is the objective. In some case, you will reject it. In other case, you will accept the null hypothesis. But you need to accept or reject. The rejecting is desirable, but this this is the objective, to reject the null hypothesis. So if you reject the null hypothesis when the null hypothesis is true, is known as type 1 error, and the probability to make this error is alpha. This alpha will be always the p-value. Okay, can you understand what is the p-value? This is the most important thing on until now. That all the topics or the few topics that that I did the the explanation or the, the exhibition or whatever. This is the most important thing. What is the p-value? The p-value is the probability to make the type 1 error. Okay, do you have questions about this concept? What is the p-value? The p-value in your final project, the most important thing is the p-value. In your final project, I need to fix the last comment. This will be the most important to you, not for me, to you. Okay, for when I will be grading your final project, it's only an element of the complete grade. But for you, for your research, the most important thing will be the p-value, and depends of the statistical test. For example, in the case of Adriana, maybe they need to employ another statistical test, not a regression analysis, but maybe, I don't know. In this case, the same. The most important things will be p-value. P-value always will be the most important thing or the most important result in a quantitative research. Do you have questions about that? Am I being clear with this idea? Daphne, Valeria, Guillermo, Yareli. Is it
So,
clear?
teacher, sorry.
Okay.
The,
Tell
the
me,
P,
Mariana.
yeah, the p-value will be, you said, the probability of making the error number 1, type 1, right?
Exactly, as you say, Mariana. One final comment. This value of alpha or p-value is called the level of the test. In Spanish, el nivel de significancia. Okay? P-value always is the most important thing in a quantitative research.
So it's like the, well, now that makes more sense that you said is the nivel de significancia. So it's like when we study the campana de Gauss, right? Like the ones that were accepted inside, and the tails, the ones that were rejected.
Exactly. As you say, Adriana or Susana, I don't know who tell me Okay, exactly as you say, this is the importance of the p-value. Okay, do you have questions about the p-value? All the all the topics that the last the all the topics before the p-value is um, it's always to see or in order to understand what is the p-value. If you understand the p-value, it's it's amazing because you are in a position that maybe some researchers don't reach out because they prefer not to look or to investigate what is the p-value. But if you understand what is the p-value, excellent. The 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 next step will be make the statistical analysis. Okay, but in if you understand in a logical way what is the p-value, so you great for you. You are in a excellent position. Okay. Okay. If you have any question, please tell me.
Teacher,
Okay, Adriana, tell me.
Jimena mentions about an exam
Okay.
the next Monday.
Okay, Adriana. Yes. Look, on next Monday, you need to complete the forms. I will share the link with Jimena and Marcelo and Samantha, and then they they will share the link with all of you. So you need to complete the forms between 8:40 and 10:20. Approximately at the 10:30, I will obtain the all the results. Okay, so it's important to answer the the forms for two reasons. The first one, because the assignment 9, if I don't remember wrong, if I remember well, the assignment 9, it's only to complete the forms. You will have 100 of grades in the assignment 9. Okay. But in the assignment 10, I will grade the assignment 10 or not. Yeah, the 10, the assignment 10 with this with with the grade of these forms. Okay. The form and the second reason is because I need a, a data to develop my statistical analysis for the next classes. On the next class, I will try to finish the regression analysis. On the next class, I need to finish this topic. On the next class, I will make an ANOVA analysis of variance. Maybe if maybe maybe 3 or 4 teams need to use this analysis, so I will calculate or I will make an ANOVA test. Okay, so I need the data of the forms. Please complete these forms on Monday during the time class, because it's important for the next analysis that I will make. Okay, Adriana, is it clear? please, if you know
Okay, teacher.
anyone that, okay, Adriana, thank you.
Teacher,
If
but
you tell me.
are questions about the topics or questions that you are going to about your investigation? I mean,
Mm, the forms contains questions about the class. Uh, 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 I don't remember. Uh, like 17 questions, I think, but 17, 19, or 16, I don't remember well. But there are questions about the class, and there are questions, general questions. Okay, some questions will be great and some questions not. Okay, but on the next class I will share with you the results. I will share an Excel with the results only for the question about the class. The rest of the results, is my database for the next classes. Okay, you don't know to study. It's only take this exam as a test, only that to know where can you, what is your knowledge until now? Only that, Adriana.
okay, teacher, perfect. Thank you.
Okay, no, thank you guys. If you don't have any question, I see you on next Wednesday. Please complete the forms on next Monday. Okay.
Yes, teacher. Thank you.
Thank you,
Okay, thank
teacher.
you,
Thank
Paola.
you, teacher.
Have a
See
good
you on
day.
next Wednesday, guys. Thank you, Susana. Bye.
Thank you, teacher. Have a
Thank
nice
you,
day.
teacher.
Bye.
Bye.
Thank you. You too. Thank you, guys.